All right, we're going live now. So
Right.
I see what they're asking now. Okay, so what they're saying for number 7 is they want you to reflect it over the line y equals -1. So the line y equals -1 is this line right here. I'll draw it in yellow. Y equals -1 means that it's a horizontal line going through -1. They want you to reflect that point over that line.
All right.
That's what they're asking. I didn't really understand, but now I see it's the formatting of it makes it look weird. So I'm going to take this point and I'm going to go over this line. So I'm going that same distance below the line. So this distance right here is 4 units. So I have to go 4 units down from -1, which would put me at -5.
All right.
That makes sense?
Yeah.
So my point would be, that would be 1, -5.
All right. Let me see that. All right. Yeah, that's good.
So for this next one, they want us to reflect over the line x equals 3. So where is the line x equals 3?
X equals 3.
What kind of line is x equals 3? Is it a vertical or a horizontal line?
Horizontal.
Not when it's x equals.
So Y is horizontal and X is vertical?
Yep. Whenever it says x equals, that means that the x value, the x coordinate is always 3. And look at this point right here. That point, every one of these points has an x coordinate of 3. That's negative, or that's 3, -5. That's 3, -7. That's 3, -10. That's 3, 0. That's 3, 3. That's 3, 5. Do you understand?
Yeah.
So that equation is x equals 3. And now I'm reflecting this point over that line. So which way do I go to reflect it over that line?
You would go down. No, or no, I think you'd go to the other side.
Yeah, you go to the other side. So how many units is that right there?
That's 3.
That's actually 4. It's kind of hard to tell.
Okay.
So I have to go 4 units to the other side, which would put me
At 1, 2, 4 and -1.
right. But which one comes first, the 4 or the -1?
The -1.
Good.
So -1 and 4.
Got it?
Yep.
Number 9, it says identify the mapping as a translation, reflection, rotation, or glide reflection. Write the rule, and then write it for a glide. Write the rule as a composition of a translation and a reflection. So we're going from EDC. So we're going from this one to this one. Can you see how it's a glide and a reflection?
Yeah.
Can you see that I'm going to take this and glide it this way, but then I'm going to flip it, reflect it over the x-axis.
Uh-huh.
So I'm going to have to use a composition of functions. I'm going to have to show 2. So they want to do, we're going to glide it first over y equals 0 is the x-axis is y equals 0, just so you know. The y-axis is x equals 0. It's kind of confusing, but it's for the same reason I told you before. When you have y equals, that's a horizontal line. When you have x equals 0, that's a vertical line. It seems like it'd be the reverse, but if you go back and watch what I was just explaining about x equals 3, then it'll make sense to you.
All right.
X always equals 0 on this vertical line right here. X equals 0 for all of these points. So that's x equals 0. Y equals 0 for all of these points right here, because you're not going up or down. Y equals 0 for every one of those points. Okay? So we're going to first glide reflect it over the line y equals 0, the x-axis. And then we're going to translate it how much?
We're going to do...
So I'm going to glide reflect it, or I'm going to reflect it first and then do what?
then reflect it first, and then you graph it.
How much do I glide it? And in which direction am I gliding it?
You go down, right?
No, because I already flipped it down.
So you go to the side.
Yeah, which side am I? If I'm going from this to this, am I going right or left?
Going right.
Right. So that's, and it's, I think, 11 units. So this is going to be first reflect it over the x-axis and then glide it or translate it to the right 11 units. So which of these is it? Is it this one, A, or is it D?
Glide. I think it's A.
Well, A is telling us to do what?
Glide reflection.
But where is it telling me to reflect it? If it says negative 11 comma 0, what's that telling you to do?
It's telling you to go down, right?
Nope, that's the x coordinate. So is that telling you to go left or right? Negative 11. Yeah. Do I want to go left?
No, you want to go right.
So this one is telling you to go right. You understand?
Yeah.
So it was D. All right. A translation is an isometry. False. A translation is not an isometry. What's an isometry? I've never heard of this.
An isometry?
Do you have a definition for that? If that's a new word to me.
I definitely do in my notebook. Here, let me get it out.
I mean, I can look it up. It says in math, an isometry or congruence or congruent transformation is a distance preserving transformation between metric spaces.
All right.
It's a mapping of a metric space onto another or onto itself so that the distance between any 2 points in the original space is the same. So a translation is an isometry. I think yes, true.
I did say it's true.
I think it's true, but let's see if it's B or D.
Yeah.
But the orientations are opposite. No, the orientations are not opposite. It would be B.
Yeah, it's B. It said the statement is true and translation is an isometry and the
An isometry just means basically a congruent image. That's what an isometry is. A congruent transformation, basically. Identify the mapping as a translation. All right, so this is like the other one, a number 11. And we're going from P, now we're going from, what does it tell you we're starting from for this one?
It says you're starting from, hold on, I'm trying to pull it up right now so I can see it better. It says you're starting from -8 and -4. Is that?
Am I starting from this one on the left or am I starting from the one on the right? Which one is my pre-image?
Oh, pre-image is 4A, I think. Is the positive ones.
That's right. It's the one on the right.
Yeah.
Because do you see it over here?
Yeah.
That's the P, that's P at QM right there. So what am I doing to go from this image to this image?
Doing translation. What are you doing? Translation, reflection, or rotation? So
yeah, and which one are we doing? Can you tell what I do to get from here to here?
I think rotation, because they're the same triangle, but they're flipped opposite directions, and one's positive and one's negative.
It's not going to be a rotation because if I try to rotate this, I'm going to look at what's going to happen. This is going to be here like this.
Oh, okay.
Do you see? Can you imagine rotating?
I get it now.
So what is it? It's not a rotation.
It could be translate. I mean, it could be reflection.
Uh-huh.
And
a reflection and what else? Just a reflection?
No, it could be a glide reflection.
That's right. And which one is going to, so you can see with the reflection, glide reflection is over the, what does this mean again? Y equals 0? What's that mean?
Mm-hmm.
What does Y equals 0 mean?
Y equals 0.
Remember what I said y equals 0 is?
No.
It's the x-axis.
Okay. Yeah.
So that's how they say a reflection over the x-axis. Do you see how I'm reflecting it over the x-axis first?
Yeah.
So the first thing I'm going to do is reflect it here. And then what am I going to do after I reflect it?
Gonna graph it on the other side.
Okay, so how am I going to do that?
Gonna go to the other side of the x-axis.
But how? Am I reflecting it or am I translating it?
Translating it.
You're translating it, right. And it looks like that's 11 units. And am I going right or left?
I'm going left.
So which one of these is the correct answer? A or C?
A.
That's right, because it's a negative 11.
It's negative.
Do you see how you have to think through that?
Mhm.
That thought process?
Yeah.
Okay, this says point AX moves 6 units right and 7 units up. Write an ordered pair translation rule that describes it. So here's how you do this. You write in X plus, it says it's moving 6 units right. So you write X plus 6, and it's moving 7 units up. So what do I do for that? How do I make it move 7 units up?
You do x plus 7?
Not X plus 7.
Y plus 7?
Yeah, because see how this is your second coordinate is Y.
Yeah.
So it's Y plus 7.
Okay.
That's the rule. So like, do you understand how that rule works?
Yeah.
Your original point here was like 1 comma negative 2. 1 comma negative 2, you just gave a map. You just gave a formula to help find the next point. You add 6 to the x coordinate. So that would be 7. Right? So
Yeah.
it's 1 plus 6, which is 7. And then you add 7 to the y coordinate, which was negative 2. So that would be 5. So your next point is 7 comma 5.
All right.
And that tells you that you're moving it up 6 and to the right. I'm sorry, to the right 6 and up 7.
Mm-hmm.
You have more questions?
Yeah, I'll just put them in right
Yeah,
now.
throw them on there real quick.
Yeah. Did we already do this one that I just put in? It looks familiar, but I can't remember if we did this exact question.
Trying to view it, but it's not showing up.
I just put it in on slide 13.
Yeah, this for some reason this sometimes doesn't it gets a little glitchy sometimes. It looks similar, but it's different. Oh wait, looks very similar. I think we did this one
Okay.
because I'm going from PQM,
Mm-hmm.
so it's going to flip up like this. So that's a reflection first, and then a slide to the left.
All right.
So the answer keys look a little bit different, but we did do it before. The answers are kind of mixed up a little bit. So it's a glide reflection, and then it's a shift to the left 11. So it would be D for that one.
Okay. I have a couple more I can drop in. Did you see the 2 ones I just put in?
Yeah, I'll get to them in a second.
All right.
It's taking a second to load them. There we go. So state whether it's a translation is an isometry. Yes. I think we already did essentially that one, right?
Yeah, I think this is another word, way to say it.
Yeah, that one would be yes. And a translation is a transformation that maps all points of a figure the same distance and the same
Translation is same translation
direction.
direction.
Yeah. The same distance and the same direction. So like if you're moving, translation is like you're moving to the left 11 units.
Mm-hmm.
That means left is the direction and 11 units is the distance.
Okay.
That makes sense?
Yeah, it does. All right. Most of the questions on the homework are ones just like that. So, here we go. Here's one.
All right. This says, given, let's see, given the points, those points, graph AR and its reflection image across the given line. So they want you to reflect it across the line. Can you see what this says here? What line would that be? The line x equals 1. What kind of line is x equals 1?
X equals 1. Horizontal.
Remember, when it says x equals, what kind of line is that? If it says x equals, it's not horizontal.
Vertical.
It's vertical. So are all of those black points the same? Yeah, those are all the same. All of these pictures are the same. But we just have to find, boy, those are, it's tough for me to even see.
Here, I found a way to blow them up. I'll just.
No, it's okay. I think I can see them okay. X equals 1 is, do you see how it's got, it actually drew in that red line correctly. See how that's your vertical line?
Mm-hmm.
You just have to look at it and make sure that these distances are all the same. If it's a reflection, you want the distances to be the same. This distance and that distance.
Right.
This distance here and that distance there. This
Mhm.
distance here and that distance there. So it's not A, because you see how A is kind of shifted up a little bit.
Yeah.
The other three, it's kind of hard for me to tell. I'm gonna zoom in on them. Okay, it's not that one. It's not B, because you see how it's close. You see how this is closer
Yeah.
than that. So it's not B. That could be right, because see how this distance right here. Hold on. You see how that distance looks like the same as that distance,
Yeah.
and this distance looks like the same as that. And that distance, so that looks like the right answer. Let me just see what the other one looks like. Oh, hold on, that might be correct as well. Again, it's hard to tell. You kind of have to count them off.
Mm-hmm.
So, dang, it's hard for me to see this. Can you tell by zooming in? I'm trying to zoom in and tell what. Did you choose D?
Yeah,
And was that not correct?
it was correct.
Oh, D is correct. So it's kind of hard to tell. You have to actually count these distances. This one looked kind of right, but maybe it wasn't.
I sort of guessed on it earlier, and I want to know why it was correct.
Yeah. Do you understand why? Like if I count these, that's 2 away.
Uh-huh.
If I count these, that looks like it's maybe 1, 2, 3, 4, 5 away, and it's 1, 2, 3, 4, 5 away. That's correct. But this one, let's see, this one is 1, 2, 3, 4 away, and it's 1, 2, 3. I don't know. That one looks right to me.
Yeah.
Oh, it's because they wrote the letters wrong. Look at what they did.
Oh yeah, they did.
That's the reason. So this picture was correct. They just didn't write the letters in the correct place. Okay.
Mm-hmm. All right, I got it. Yeah.
That good? You feeling better about this stuff?
Yeah.